Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we go through translations of exponential graphs. So we know that an exponential, a basic exponential, is y equals a to the power of x. We're looking at graphs of the form y equals a to the power of x plus b plus c. So what do these coefficients b and c do? Well, it turns out they do the same to this type of function as they do to all other functions. So remember, if you replace fx with fx plus c, if you add a constant to the end, the constant moves the graph up and down. This one's nice because it goes the way you'd expect. It goes up if c is positive, down if c is negative. If you replace x with x plus b, so we've got like the addition in the brackets here, that shifts the graph left and right. But this one gets a bit confusing. It goes in the opposite way that you'd expect. If this number here in the brackets, if b is positive, it goes left, which you wouldn't expect. So that's what I mean here. b is greater than 0 goes left, and b is less than 0. b is negative means it moves to the right, sort of the opposite way that you'd expect. So let's start by quickly drawing the graph of y equals 2 to the power of x. So how this graph comes about, we can use a table of values like we did in the previous video. So let's say we now want to graph y equals 2 to the power of x minus 2 minus 1. So the graph of this will be the same as the graph of this with just a few translations added to it. So firstly, note we've replaced x with x minus 2. This is the b value we're talking about here. So replacing x with x minus 2, our b value here is negative. So this is going to be shifted 2 units right. Again, that b value goes the opposite way that you'd expect. You'd think negative would go towards the negative side to the left, but it goes the opposite side. So firstly, to get this graph here, we're going to take our red graph and we're going to shift it 2 units right. So then the other thing, of course, is this minus 1 here. That's like our c value. That shifts it up or down. Because it's negative, it goes down. The c value goes the way that you'd expect. So we know that y equals 2 to the power of x has an asymptote on the x-axis. This graph can never hit the x-axis. It gets closer and closer but never touches. So if we shift this down by 1, the asymptote's going to be down here. So the asymptote of our green graph, y equals 2 to the power of x minus 2 minus 1, its asymptote will be here. So this value of c gives you the value of the asymptote. So of course, remember that exponential functions only have one asymptote. It's always a horizontal asymptote, unlike hyperbola, which had 2. Okay, so now we can graph this. What's the graph, this green graph, going to look like? Well, this is how we can think about our translations. See, if it's just y equals something to the power of x, it goes through y-intercept of 1, because anything to the power of 0 is 1. So y equals 2 to the power of x, 3 to the power of x, a quarter to the power of x, all of those would have y-intercept of 1, 0, 1. So let's shift this point according to these values here. So we're going to shift it 2 values to the right and 1 down. So it's going to be here. Now, different people will need a different number of points to see what this green graph is going to look like. So that's fine as well. We could shift any of the points, 1, 2. We could also shift that. We could shift it 2 to the right and 1 down. We could do the same to this point. We could do the same to any point we wanted. But we can probably see now what the graph is going to look like. See, before it gets to this point here, which was where we shifted the y-intercept, it's going to get very, very close to, but never actually touch the asymptote, and then it's going to start to rise and rise very quickly. This is what the graph will look like. We have taken this red graph, we've shifted it across 2 and down 1. So just one final word, make sure you can use your graphics calculator to graph these and check your answers. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.